Alright everybody, welcome to part 2 of the video for section 5.1. Still talking a little bit about the basics of midpoints, and this one doesn't exactly have to do with midpoints exclusively, but what we're going to be talking about today in this video is we're going to be talking about missing coordinate problems. Now I don't have a note sheet for you on this one, so you're going to need to get out a piece of loose leaf paper, make a few little sketches to take these notes. So please make sure that you have that ready, something to write with, and as soon as you do, unpause the video and get ready to learn about how to do these problems. Alright, now that you have your supplies, here we go. So these problems are going to work in the way that you're going to have to fill in missing coordinates in places. So let's say, for example, that you're told that you have a rectangle. Well, and we know two of the coordinates, and you'll notice that the coordinates don't actually have a number value. So we're pretending that, well, we actually don't know the scale in this drawing, on this coordinate, so we don't know that each box means that it's 1. So we really don't know what those numbers are. But you'll notice that this point up here, for example, has the coordinates 0a. And what that means is, we know that the x-coordinate is 0 because it's on the y-axis, but we don't know how far up it is. And similarly, this point down here, s0, those coordinates, we know that the point has a height of 0 because it's on the x-axis, but we don't know how far over it is. Again, remember, we don't know how big these numbers are as they're increasing, so we don't know how far over it is, really. So then we're asked to figure out what these coordinates are. And what we have to use is the information that's given to us already in the problem to help us do this. And we need to know some things about these shapes. For example, rectangles. We know that they are 90-degree angles at all corners. And we also know that these two sides are parallel, and these two sides are parallel. So it makes it a rectangle. We also know that this side and this side are the same length, and that this side and this side are the same length. So we know a lot of important information. And what it really all boils down to is we know that if this point has a height of a, then for this to be a true rectangle that's going straight along these lines, this height over here is going to also have to be a. And similarly, if this is s units over to the right, then this point up here is also going to be s units to the right. So putting those pieces of information together, we're able to figure out that SA are the coordinates of that last point. And this is going to be really important for what we're doing way later on in this chapter. So these ideas are going to be coming back. We have a few more examples that I want you to see. Here's the next one. So fill in the missing coordinate. We have an isosceles triangle this time. So you can see the isosceles triangle is centered right here on the y-axis at the point 0c. And we know that the coordinates over here are b0. And we're looking for the coordinates for this point over here. Now, the fact that it's an isosceles triangle is really important, because what that means is if it's being split right down the middle, like it is by the axis, that means that this side's length and this side's length are congruent. They're the same length. So if to go from this point at an x value of 0 over here, we know that that is a length of b, because the x-coordinate for this point is b. But what that means is that going in the other direction, this part of it is also going to have a length of b, but it's in the negative direction. So that tells us that our x value for this point is going to be negative b. Because if this went this way, by b, then it went this way by b as well, except in the negative direction. And we can see that on this point, the height of the points have not changed. The height over here was 0 because we were on the axis. We're still on the axis, so the y value there is 0. So the missing coordinates are negative b, 0. Notice that we didn't really use c at all in this problem. We didn't really need it. It was important, though, that we were on the axis with our center point. Last example, a square. So let's say that we're told that this point here has the coordinates 0d. What that means is that this side has a length of d. Now, since we're dealing with a square, if that side's length is d, then all of the sides' lengths are also d. Because it's a square. All of the sides are the same length in a square. Now, what that means is, this point down here, our x value, we're starting at 0 and we're going to d. Our x value is d, y value 0. This point up here, right there, we've gone d over to the right, positive d, and we've gone d up. So this point's coordinates are d and d. And again, the reason we know that is because to get to this point from the origin, we went over to the right d and up d as well. So we know that our coordinates are d, d. It's sort of a special case of the rectangle. So that's how you handle this type of problem. There is one like this on the homework for section 5.1. So make sure you watch this video before you try that out. Thanks for watching. See ya in 5.2.